Good afternoon, everybody. Thank you, Per, for inviting me here. I see it actually as a promotion since last conference I was invited to was VLDB. This is extremely large, so this is the next level, I guess. Today I wanted to cover a bunch of topics, but if I just can convince Per to move Nutanix from scale up to scale out quadrant, I think I'll have achieved my goal here. And at Nutanix, we've been looking at a whole bunch of problems in the enterprise data center, and we see it as a journey. There are many phases to this journey. I'll try to touch on each of these phases, and the reasoning behind that also bring some of the technical insights that we have had along the way. We call it the journey to the enterprise cloud. The goal is to make infrastructure invisible. Just like we have electricity out here, we don't see the wires, and we have the confidence to put them behind concrete walls. That kind of confidence is what we need in our data centers. While all that is important, it needs to be both simple, reliable, and all the goodness that we need. Few slides here from our marketing team. So not really my style, but talking about business today is IT, depends more on IT. Our marketing VP goes to Nordstrom, I just go to Walmart. But they buy clothes from Nordstrom, and the observation there was Amazon came and changed the game, right? You can now easily buy stuff online, and that forced the business to now evolve and go to their IT org and say, I need to be as agile as Amazon. That changes business. So IT now has to move as fast as business wants to move, and if IT cannot move, then business is dead. Same observation. I had Comcast, few video on demand. I was really happy until Netflix came along, and then it was tough time at Comcast. Finally, they came up with Xfinity, whether they succeed or not. But if they don't have this, they are dead. So the observation is that the web, the internet, the Amazons of the world, Googles of the world are changing not just the IT industry, but changing all businesses, right? Whether you're a clothing business or whether you're a cable provider. You have to evolve fast, and everybody sees that there's an example in AWS, and they want the same thing from IT. So what is there that we can help from as technologists? What can we do there? And that's the first observation is, what does business need from IT? So let's understand that so that we can see what solutions it requires. First aspect is IT needs to be frictionless. So fractional consumption, I only want this much for this season, so I need X petabytes or so much CPU. So this is the fractional consumption. I don't have to buy everything on day one, worrying about what I need for 3 years because upgrades are slow, purchases are complex. Instant delivery, Amazon with the drones, or AWS with swipe your credit card, you get your VM. In the enterprise, it's very hard. It takes weeks, months. That's what they want. Invisible operations. Operations are always there, but we don't want to deal with operations. At least businesses don't want to see how operations are done. It needs to be invisible. And security and governance needs to be there, but effortless. This kind of experience is what we get from AWS, increasingly other cloud providers, Google, Azure. But at the same time, enterprises, where we focus at Nutanix, they want control, right? Which is the other angle. And if you think of frictionless control, it's kind of an oxymoron kind of phrase, but actually that's what's needed. So you have to, maybe there's a ball, you're holding it, and it's frictionless, but you can still control where it's going. Now the control that's needed is balance between owning and renting. What Per beautifully articulated, there's a chasm, and then there are two sides to it. One is the capex, one is opex, and businesses want to decide what goes where. They need control. They also need to control where the data resides. It could be credit card information that they really are worried about where it goes. Proximity, speed of light, data placement, all these things are important. SLA for every app. Some apps are more important than the other. They do not like noisy neighbor problems in the public cloud, some amount of more control is needed for the business to have more assurance that their applications will work well. And finally is choice and freedom from lock-in, where just like I can choose who my electricity provider is, I can choose where I buy clothes from. Businesses want to be able to choose what hardware vendor, hypervisor vendor, software vendor, cloud vendor they go for. And just because they have already invested a whole bunch should not be a reason that they cannot move. So the lock-in is what they want to avoid. So this is the high level. And what we define as enterprise cloud is something that is trying to solve this problem, right, of providing frictionless control in the data center, where you have a full stack. There's a reason why you need to now manage the whole stack to provide this frictionless experience. Zero-click operations, flexible consumption. The security and control is obviously very important, both in the public cloud and private cloud. And finally, there's app mobility, which is my application is running on one infrastructure. How can I move it over to some other place with a single click, right? If you're running on one cloud, how can you move to another cloud? If you're running on one data center, how do you move to the other one? So this is a journey, and we've defined it to have 3 sort of steps. One was making storage invisible, followed by virtualization invisible and cloud invisible. So let me talk about each one of these. We started off with making storage invisible because this is the source of inertia and this is the source of lock-in. It's relatively easy to spin up your application somewhere else if it's only about the code that you have to bring up. But if you have to take your data and bring it up some other place, you have to actually migrate the data. And if you have a petabyte of data, I mean, it's going to take you weeks, if not months, to figure out how to migrate. So the inertia and the gravity that comes in the data center is because of data. So first thing to tackle is how do you make storage sort of stop becoming a source of slowness in the agility. So this observation was the foundation of hyperconverged infrastructure. You look at this side, this is a typical 3-tier architecture. There's an application running, virtualization layer, you could have any hypervisor, running on servers, connected through a SAN fabric to dual controllers, which are the storage controllers there. And you have a mesh of connectivity connecting the servers and the storage. Now, this worked well for a decade or two, and then there were many trends that impacted this. One was virtualization became more popular. VMware did a good job. Servers on the compute side, people wanted to consolidate their applications. Utilization was fairly low, so you consolidate, utilization goes high, it's good. On the storage side, flash became more popular, and it became harder and harder to put flash on this side of the network, where the network was becoming a bottleneck. So what this led to is folks like us, I mean, we started off in this space fairly early, but now others have followed suit as well. It's the notion where you can take the compute, the storage, and the storage networking and combine it into one platform. And that platform is not special in any way. It's basically a x86 server that you'd get. It has a motherboard with CPU and memory and direct attached, as you were saying, right? Direct attached, JBODs are in fashion again. So they are attached to the server. So all the compute, memory, and storage pieces are there. There's basic networking, Ethernet networking, nothing special about that. All the intelligence to take this and shrink it into a small footprint, it comes in software. On top of that, you still need a hypervisor layer and the application. This is an integrated compute and storage. We didn't coin the word, but the industry terms this as hyperconverged, which is essentially saying compute and storage has come together. But this is just hyperconvergence, fortunately or unfortunately, talks mainly about the hardware, what's happening to hardware. The real observation here is more at the software layer, right? If you look at the last couple of decades, there is a common theme in the data center. Compute and data want to get closer, right? Big data was about taking your compute application, breaking it to tiny pieces, and shipping it to where the data was, right? That's big data. Hyperconvergence actually is about taking a storage controller and storage, chopping it into small pieces, and moving it to where your application is. Again, storage and compute need to be together. Why? Because Intel is doing a great job, and Intel is giving you more and more compute power and also giving you faster and faster storage. So now you can take your compute power, take your data, and create information for the business. And finally, business needs this information to succeed and make more money. See, at the end of the day, you have to take data and create information out of it. So this is the trend, and the hardware form factor, as it manifested here, is one way of bringing compute and the data together. So doing it right was also important. Anytime you take a piece and break it into tiny pieces and ship it somewhere, either it was compute and big data, or hyperconvergence here, shipping small storage controllers, we have to take care of the distributed nature of it. It's a distributed systems problem. It's a scale-out problem, right? We have to build it for failure and so on. So first thing was off-the-shelf x86 servers. The reason why there should be no dependency on hardware, because remember what we started solving is the data gravity, the viscousness of data. So we want that the software should be portable anywhere. If you get a new server or you want to migrate your application, everything should be freely flowing to different places. So that's why there should not be any hardware crutch that slows down, because that becomes a silo in your data center. All intelligence in software. Scale-out architecture is a must, right? Everything that you build in a distributed system, you have to make sure that the resources that it consumes is not proportional to the size of the cluster. If you do that, it's actually a simple statement, very hard thing to do on a daily basis in engineering. If you do that, then as your cluster is growing, hotspots do not appear. So there is no single node that's a master that has to know about everything in the distributed system. That's why, although we built a storage system, but it's built very differently in the inside. Outside, it's the same common features that you see in a storage product. Where inside, it's a Zookeeper for split brain avoidance. It's Cassandra for metadata bookkeeping. There's a MapReduce engine that's built custom inside to manage all the metadata and so on. So that's some of the internal details. Also, it's important to build self-healing systems, and the reason is, in large data center, if one node fails, you don't want somebody to be rushing to fix it. That's the pet versus cattle analogy that Per also mentioned. Since you don't want to go rush fix it, that means you need a system that will self-heal. So you have an n+1 architecture, n+2 architecture, where you can let things fail as long as there's enough capacity in the remaining cluster. It will come back to a healthy state and take more failures. So what becomes important is not that, hey, there's an alert, now I go fix it, but rather, do I have enough capacity remaining? What is the predicted trend of capacity in my cluster? And that's why analytics becomes more important at large scale. And that's some of the fundamental things that differentiate web scale engineering versus just regular engineering that solves specific problems in the enterprise. So these are the sort of doing it right philosophies. We've learned it from the various large companies in the world. The key thing that we are trying at Nutanix, it's also very hard, and we'll know whether we succeed or not, is bringing that web scale capability in a very small form factor like 3 nodes, or a very large form factor like the entire data center. So how can we build technology that can both scale down as well as scale up? It's not only about scale out, but also scale in and become really small. And the reason that's important is because you want the two worlds to be able to talk to each other, right? Enterprise cloud is about I want to decide what to own and what to rent. If I'm owning, it will probably be a small footprint. I can't own a very large data center like Amazon. But if I'm renting, it's most likely somewhere in the public cloud. The scales on the two sides are extremely different, but I want them to talk the same language. To talk the same language, just the API level is not enough. The data planes also need to talk the same language. So otherwise, your data won't move. It's only the management plane that's portable, not the content. So that is why it's very important to figure out the common stack that can work across all the spectrum of the scales. And that is basically the divide that Per was talking about, where you have the scale up, the CapEx model on one side, and scale out and OpEx model on one side. Enterprise cloud, and our hope is that we can build one stack that can service both the needs. It's a very hard problem, but we feel that it's doable. And once we do it, it gives flexibility that the enterprises are really looking for. So this is an architecture of what we built in the first layer, making storage invisible. The multiple nodes, say n nodes. Each node has a hypervisor on x86. They're running virtual machines, and those virtual machines are your applications. Each node has a controller virtual machine. This is the mini storage controller, if you will. And these talk to each other, form a cluster. This Cassandra, Zookeeper built in. Everything is scale out in nature. Each controller virtual machine has a dozen microservices for different needs. The UI, the statistics, the alerts, all these are also microservices. As the cluster grows, the capability of these microservices grow. And together, they create a distributed storage fabric with all the features that you need. That's just the first step of the journey. There are a lot of benefits to our customers. You can buy, pay as you grow, deploy, small, manage, scale, and so on. Next step is now once you figured out how to move data around, right? And there are no silos to manage, and there are no separate hardware that you have to buy to attach to storage and so on. And the hardware is commodity Intel servers, Intel-based servers. You think of what's beyond this. So beyond that is about, okay, is my provisioning layer something that is scale out? What I mean by that, today in the enterprise, if you look at, say, VMware, vCenter, Microsoft SCA, VMM, OpenStack deployments that are not, that's the default deployments, they are not scale out. When that management plane is being upgraded, it's actually down. AWS is never down when it's upgrading, right? You cannot throw a million IOPS at the AWS management plane and bring it down. That does not happen. So just like at the data plane, there are some requirements of performance and always on nature. Same thing is true at the management layer. If you don't have it at the management layer, then you will not automate your data center, because then again it becomes a pet versus cattle thing. You want a management plane that's always up. To do that, we have to make sort of virtualization invisible. Invisible means I don't worry about it. In fact, not many people worry about what hypervisor Amazon runs. It's some version of Zen, but they don't sell the hypervisor. Nobody talks about it. That's what we want to do in the enterprise. So again, looking at the stack, so you see what happened. There's the hyperconverged systems with storage services in the virtualization stack and the app running there. What has happened in the last decade or so, the hypervisors like VMware's ESXi has been a leading hypervisor. It has compensated for virtualization awareness, the lack of virtualization awareness in the storage stack and the networking stack, and that has bloated the hypervisor. The time has come to actually make the hypervisor really lean and simple. Or maybe if you go with the Docker world, you don't need a hypervisor. Just an operating system is a good resource carver, if you will. So what needs to happen is that the storage function from the hypervisor needs to go away, because the storage function that you're using is virtualization aware. And then the hypervisor becomes simple enough that you could also embed it and make it invisible. So that's the next step in the journey, where when you talk about a solution for an enterprise cloud, the hypervisor is just one component of it. It's not something you worry about. It's just like dedupe used to be a separate product, now it's a feature. Same thing, hypervisor is a feature now. Making it built-in has a lot of benefits, actually. Simplicity, of course, it's a simple solution. Scalability is important. The way you implement the VM management has to be done in a better way. So like what we chose was, again, build it on top of Cassandra and Zookeeper, so it scale out, has all the goodness of using a NoSQL database. The same thing, just like what we did for the storage layer, the same performance benefits come to the virtualization layer. Security is important because as the cloud is becoming more popular, businesses depending more on IT, the applications are getting more and more connected. So since the east-west traffic in data centers is growing, we need to worry about security more and more. And the best thing for security is to have a smaller footprint, do less. So the lesser the hypervisor does, the more secure it's, theoretically to make it. That's one of the benefits there. So if you look at this picture now, these are the traditional things, a lot of technologies that customers have to worry about, from networking, storage, SAN, fabric, compute. All of that shrinks into a simple stack, which is what Nutanix sells. But also with the virtualization layer, now we have our own hypervisor called it AHV, also being built in just in case you don't really care about the hypervisor, right? Although you do have a choice with VMware and Microsoft. So it's not a business where we are saying, hey, we'll build a hypervisor and sell it separately. That's not the case. The observation is that the hypervisor should be built in. You should not worry about it, right? What's really important is the applications, and nothing below the application is what the customer wants to worry about, right? Same thing when the consumption layer, there are a lot of tools that people have to use. It just simplifies if you have one stack, so you have one consumption layer, one place to manage things, right? And finally, let me talk about what we mean by making cloud invisible. And this is the one step in the journey where the industry as a whole is furthest from. In fact, we are going slightly in the opposite direction, where today, when I'm writing an application, if I have to run on AWS versus I have to run on Azure, I have to see what APIs are supported on which cloud. There's no compatibility between clouds. And so as an app developer, I don't want that kind of lock-in, right? And once my data is there's no way of actually taking that data out and moving somewhere else. I have to write further tools to do that. So this is where the Docker movement is somewhat helping, where at least the packaging part, you'll be able to make it portable. But still the stateful part, if it's an S3, you need another S3-based, API somewhere else with the same functionality. So actually, it's very hard to hide the cloud's nature from the application. This is where we want to go and help the industry. Essentially, I would like to draw an analogy here and just leave with that thought. Amazon, the way it was built was, there's an infrastructure, there's a hypervisor choice, and then there's compute and storage on top. Now, since it's a cloud service, you have connectivity layers. And once you have connectivity, people are consuming these basic services, which are fine. There were other services that were added for applications to go interact deeply. While it's good for applications to go use these database services and SNS and messaging service and all that, they also get locked into these clouds. So fundamentally, the problem is, how do we see a world where we will be able to make these applications portable from one environment to the other? That thing was solved for virtual machines with the hypervisor guys. Hypervisor said, we will invent vMotion, and that's how you get liberated from one hardware to the other. The vMotion for public cloud has not been invented. And that is a problem we are creating for ourselves because applications are changing, right? They are essentially divorcing the OS, they're divorcing the hypervisor, they are becoming scale out. And what we used to do with one VM, does nothing for an application. Application spans hundreds of VMs. So we have to rethink that. So towards that journey, what we are saying is, okay, first of all, we believe in giving choice. At the hardware layer, this is last slide. Hardware layer, we have some choice. At the hypervisor layer, we provide choice. ESXi, Hyper-V, HV, we're working with containers. We also can spill data to public cloud as well. So there's some amount of choice that allows portability of applications. And on top of that, there's a management plane that we want to build that will span public, private cloud. Again, the analogy is the Apple iPhone. I can go to the App Store, select my app, click install, and it just works. We believe that the one day will come where in the data centers, that's deploying an app is as simple as that. So, and then create an open platform where the software vendors find a standard way of creating and deploying, creating and providing apps to customers, where there's very little confusion as to whether it will run or not, while the customer gets the freedom of going from one environment to the other, including going away from Nutanix if they want, without any lock-in. So that's the overall objective here of what we call the enterprise cloud. That's all I had. Thank you.